All right, so this is the video for modeling data with curve and line of best fit. So you can see we have four basic models we're going to be talking about. The first one's the quadratic. There is the standard form of a quadratic. You should know that. The data that I've got modeled here fits a quadratic model because notice how it dips down and comes back up. We're not going to be able to draw a parabola that hits every single one of those points perfectly, but that's why it's called a scatter plot. This next one is a cubic function, and that's because it's increasing, and then it dips down and decreases for a while before it begins to increase without bound. So that data is best modeled by a cubic function. So when you see different scatter plots, you're going to use these notes here to determine which equation, which model is going to best fit that data. This one's an exponential function. You should recognize this. It's increasing exponentially there. And then this last one appears to be modeled by a linear function, straight line. Of course, those are standard form for the linear and the cubic function. They got cut off there. We're going to use the graphing calculator quite a bit. So you'll need a graphing calculator, preferably Texas Instruments, so you can follow along. And we're going to start with this problem. You're given a table. We're going to enter this data in the calculator here in just a second. First thing we need to do is we need to figure out what's our x values and what's our y values. X is our dependent variable and usually the time variable. So x is going to be representing the years since 1950. So this is really important that x represents the years since 1900. And that's because we can't put in 1950, 1960 in the calculator. Those numbers are probably going to be too big for the calculator. So instead, what we're going to do is we're going to put in 50, but we have to realize that 50 represents the year 1950. And then we're going to do that for all of these data values, for these x values anyway. And then remember, the year 2000 is not 0. It's 100 because it's 100 years since 1900. We're not going to change the y values at all because they're already scaled for us. They are cost. The cost of buying a median home in thousands of dollars, so 7.3 actually represents $7,300. So now we're going to make a scatter plot. Again, our x's are going to go across the bottom. So I'm just going to count. I'm going to start at 1950. And just to save space, I'm going to count by tens across the x-axis. But I'm only going to label every other one, just so it doesn't get too junky at the bottom. So 1950, 1970, 1990, 2000, 2010. And again, this is years since 1950. And I realized I had year 2000 in the wrong place, so I fixed it. Again, you can count by different numbers, but you want to make sure you fill up most of the x-axis. Same thing with the y-axis. And then on the y-axis, again, that is cost in thousands of dollars. So pick a good number to count by on the y-axis. I'm going to count by 25s. Remember, that's $25,000. And I'm going to skip every other one. So 25, 50, 75, 100, 125, 150, 175, 200, 225. And then we're going to make a scatter plot. A scatter plot is just an estimate of these points. We want to put them in about the right place. And then we can determine which model will best represent this data. So those are those points plotted, and then we can see this looks like an exponential function. It's not perfect, So we can draw a curve of best fit. We're not going to connect the dots. You can't draw a perfect curve that's going to hit every point perfectly, although it's pretty close. So that's our curve of best fit. So now we're going to use the calculator to sketch this curve to make the scatter plot and see if they match up. Then most importantly, to answer question B here, come up with the equation of best fit. So to do this, you might want to reset the calculator's memory first just to make sure there's not a weird setting. So second plus sign 7, 1, 2. And then we're going to follow the directions of those calculator handouts that you should have. So first we're going to enter the data in the table. So to do this, hit Stat and then choose number 1 for edit. You should have an L1 and an L2. Your X's are going to go in L1 and your Y's are going to go in L2. And again, we're not going to type in 1950. We're going to type in 50, 60. If we type in the 4-digit year, the calculator may not be able to determine an equation for us. So every time you type in a number, hit enter. And then the Y values go in L2. If you do not have a TI calculator, you can still do this on different, like Casios. If you have a Casio or even an Inspire, you probably can still do these steps, but the buttons that you press are going to be different. So you'll have to look for a different tutorial online to help you out with that. All right, so we've got all the points in there. Make sure you've typed in everything correctly. If you make a mistake 9 times out of 10, it's right here when you're entering the data. So now to see the scatter plot, we're going to press Y equals, and we're going to use this up arrow to go to plot 1, and we're going to hit enter to highlight plot 1. Press the down arrow just to make sure it's highlighted. And then we're going to press zoom. And I believe it's number 9. Yeah, zoom. I think it's zoom 9. Yeah, zoom 9. And you see a scatter plot. Looks awful lot like the one we've already done. So now we need a curve of best fit. So to do that, you're going to go back to the main screen of the calculator. So hit second mode. And now to get the equation, we're going to press Stat. We're going to scroll to the right to calculate. And then we're going to scroll down, look for the exponential regression equation. It's number 0. You're going to hit enter. Different calculators will do something different here. If you have a different version of TI, you may have to enter a few less times. But basically, you want to keep hitting enter until you're able to calculate that equation. And it should calculate an equation for you. We're going to round these decimals to 2 places. So our equation is going to be Y equals. The A value is 0.36. The B value is 1.06. And we're going to raise that to the X power. Now, if you want to go to Y equals and type in that equation, you can. But I will tell you, when you graph this, it's not going to be a perfect curve like we drew on our papers. So to get the perfect curve, you're going to go back to Y equals. Instead of typing in this rounded equation, we're going to press the vars button right here. So vars, and we're going to go down to number 5 for statistics. And then we're going to scroll to the right to where it says EQ, and we're going to choose number 1 for regular. I think it stands for regression equation. And then it'll put in the entire equation in there. There's a bunch of decimals. You won't be able to see the equation all at once. You just have to trust that it's all in there. Hit the graph button, and your equation should go, or your curve should go through all those points perfectly. Now we could use the calculator to answer these questions. So this one says, according to the model equation, what was the median cost of a home in 1975? Now remember, X is our years since 1900. So 1975 really means X equals 75. So we're going to look at our table. So second graph. You can do this two ways. You can scroll down until you get to 75. That'll take a while. The quicker way to do this is to press second window, and you can tell the table where you want it to start. So we want it to start at 75. We want it to count by ones and then go back to the table. Second graph, and then immediately it takes us in the year 1975. The median home price is approximately $29,368. So again, if you typed in this equation in for y equals instead of the full equation with all the decimals, your answer is going to be off by quite a bit here because you rounded those decimals. We're doing the same thing for part D, except for 2020. This is 120 years after 1900. So go back to second window, and now we want our table to start at 120. His second graph, and then we can see in the year 1920, the median home price, 2020, the median home price is $409,410.